All right, next up is Vagrant Cascadian. He's giving a talk about cat herding development boards. Vagrancy, over to you.
All right, take two. I'll be talking about cat herding development boards. It's great to be here in Brazil 15 years later. It was my first DebConf in Porto Alegre. There will be no cat pictures. You'll see that in a moment, or as the case may be, you won't see it. Myself, I was a user of Debian around 2001. I think I originally tried to install it in the late 90s sometime and failed a bit. Beautiful FAQ and constitution and all that stuff, so it was in the back of my mind. I was invited to go to Brazil in 2004, and well, I just started contributing more and more since. Somewhere along the way, I got like that cool new Debian maintainer status, and then people are like, you should be a developer. So all that happened, and other than when I'm futzing around with ARM boards, I like to be thrown around a bit, so that's more or less who I am. There's some more and some less. What is a development board? For my purposes, it's pretty much an ARM board. Frequently, they come without a case, so you can like drop metal things on it and sparks might fly. But ideally, you don't drop anything metal on it and make sparks fly. But it's a computer, but it gives you access to plug into various bits and pieces. But not all development boards look like that. This one in particular is a BeagleBoard X15. So one of the ways I started getting involved more and more in development boards is through U-Boot. And at the time, I was helping BeagleBoard.org transition from whatever operating system they were using before over to Debian. And it had been, it was like late October 2013. It had been several months since the last Debian upload, and there were a couple platforms I wanted to add. At the time, it was about 18 platforms. So, you know, I filed a bug report, basically saying, I did some work, and I could help you with it, but I can't really commit to this. And as often with Debian, basically it was like, here you go, it's yours. So I've been maintaining U-Boot for, I guess, about 6 years now. And you know, we went from 18 supported platforms, and the support was arguably dubious because I don't know that anybody was actually testing it, to now 89 supported platforms. So you can look up, and one of the ways that we make this possible is we need people to maintain these boards. While in theory I could maintain 89 boards, that's like U-Boot releases approximately once every 2 to 3 months. How many boards can I test in any given month? That gets to be a little ugly. So I ask other people to help with at least just testing it. And how many people does it take? Well, there are about 40-ish people who are helping to test boards, at least allegedly. Though I do end up doing a bunch of the testing myself. So there's kind of a status page about all of the various boards that are tested. You know, it basically lists, I tested this board, you know, with this version. Maybe there were some quirky notes or something. One of the main things I do with U-Boot is I interact with upstream. So I spend a lot of time on the IRC channel for U-Boot. And I don't subscribe to their mailing list because it's a bit of a flood of, it's just a flood of email, and I could not keep up hitting delete fast enough. But they have a really wonderful patchwork thing that I use to look for patches. And so you can basically submit a query searching for some board or some other string. And that allows me to catch the things I would have got had I gotten the email that I wouldn't have had the time to follow all of them, so I can search for things specifically and then download the patches and maybe apply them to my package. One of the things that really skyrocketed the number of boards I work with is I work on reproducible builds, and I'm maintaining a board, somewhere in the ballpark of 20-some boards that are rebuilding Debian constantly. I would not recommend hiring me for cable management. Another main thing I get involved with is the Linux kernel. Upstream, there are some Git repositories. I usually need to follow both the regular Linux repository and the Linux stable. And I like to merge them into the Debian packaging, which, oh dear. Yes, so I like to I follow things upstream. Similarly, I do not subscribe to the kernel mailing lists. It's just a flood of emails, even crazier than U-boot, and I couldn't even keep up with U-boot. But they also have a patchwork repository where you can search for patches. I like to use the Debian kernel packaging. Many developers who work on boards upstream, they'll build a kernel configuration that will be targeted for their board or their narrow range of boards. But Debian kernels, being very universal, we try to have a small number of kernels that can boot a large number of boards. But what this often means is the people developing these boards have no idea what a modular kernel looks like, or they understand the concept, but they're not actually doing it. And so you have to hunt down all of these different values in the kernel configuration in order to make a modular kernel work with the out-of-the-box Debian packaging. And this gets to be, every once in a while, I'll even run into bugs that work fine when you compile it in, but if you enable it as a module, it just doesn't even work. So end up going through some bug reporting cycles, maybe nudging some people in IRC, because while I can stumble through a patch in C, generally, if you want to get it accepted upstream, somebody else should probably do the writing. But I talk to those people, and we work together, and we come up with a solution. Another package in Debian you typically need to touch in order to get reasonable support for a board out of the box is flash-kernel. This generates some boot scripts. It also copies DTB files into the boot directory. And while I do recommend using flash-kernel, I'm not a huge fan. The code base, the name is even flash-kernel. It's about flashing the kernel to the device. But most of the devices I work with, you actually just end up copying some files around. And I have fantasies of someday rewriting it a bit to not really require a flash-kernel. Possibly even doing crazy things like copying all of the device trees into the boot directory so you could boot multiple boards with a single image. Imagine that.
That's
crazy talk indeed. Speaking of crazy talk, I love Debian-installer. It's a really amazing thing. I have some frustrations with it, but let's say, so once you get a bootloader into Debian, I'm mostly familiar with U-boot, although there are some EFI options available. You get the kernel working in Debian, and you get the flash kernel working. You're pretty much ready to give a go at trying to add support for Debian-installer. What's really cool is if you've done all the work to get the kernel patches upstream, the bootloader stuff upstream, and your patch into flash kernel it literally is often a single line patch, which, I don't, maybe you don't know coding too well, but you can probably write a one-line patch. It's pretty much you copy and paste the other board that's kind of similar to the board you're using, and then you change the name. It's pretty realistic if there's decent upstream support for a board to add support for Debian-installer. That said, in Debian-installer, the kernel module UDEBs are sliced up very fine-grained. And if you're working on trying to enable support in Debian-installer for the correct UDEBs, you're going to have to figure out exactly which UDEB package for the particular module you're using needs to go into. Additionally, there are some module dependencies which aren't really dependencies on ARM boards, and these are really frustrating. Basically, let's say you've got a you want your USB support to work, obviously, and it requires a voltage regulator of some kind. There's no technical way for the kernel to represent that this is an actual dependency, and so you have to kind of just pour through the device tree information and try and figure out which modules do I actually need installed in here, and it's a bit of a mess. And if you happen to have the same kernel module in multiple UDEBs, the kernel package will fail to build. So this is one of my least favorite parts about trying to add support for debian-installer. But on a good day, basically you can grab one of those SD card images generated. You take the firmware part, which in the case of ARM-HF is usually a U-boot image, and then the partition image, and you concatenate them together. You create your test image. And then if you're doing a new board, you have to manually install the U-boot image to it. Something along these lines. It'll vary a little bit board by board because it's ARM. But then you can dump that to bootable media, SD card, or possibly USB, and off you go. But oftentimes, because of the aforementioned module problems, I have to use this trick. So basically, I download the Linux image package, I extract it, and then I create a CPIO archive that we then append to the initrd and then copy it onto your boot media. So this way, you get a very big initrd with all of the kernel modules, because I can't be bothered to track down exactly which kernel modules we need. So then, you're working with a lot of this stuff. I started working with the pinebook. This is an ARM64 board. Unfortunately, it's not in a state where I can do the presentation on this, but the actual presentation was all written on my pinebook, which I've been using for much of the last 6 to 8 months as my primary laptop. So this is an ARM64 capable board. But one of the really annoying things that this needed that none of the 32-bit boards needed before was arm-trusted-firmware, which has since been renamed to Trusted Firmware A. I haven't quite caught up with that in the packaging or even understand the rename. I would love help to explain to me what's going on there. But arm-trusted-firmware is kind of like an early pre-boot sort of thing that sets up various environments to, it's roughly correlated to, what's it called on Intel? The management engine stuff. It plays around with some of that sort of thing. It might set up the RAM timings. It enables things like virtualization, other stuff like that. So, but the vast majority of what I do, I've been maintaining ARM-trusted firmware in Debian for a while now, and Kilobyte, who's here at DebConf, actually did the precursor work where he built a fork of ARM-trusted firmware off of the Allwinner repository, which has thankfully since been upstreamed, and so we can have one ARM-trusted firmware in Debian that supports more than one target. But like I said earlier, the vast majority of the work I do really amounts to I build something, I have an issue, I poke people on IRC in the various relevant channels, be that Linux Sunshi for Allwinner boards, Linux Rockchip for Rockchip boards, and Linux mLogic for mLogic boards. And there are usually tons of really helpful people on Debian ARM. And so consequently, thanks to Debian for creating all this sort of thing, and Debian ARM, U-boot, Debian kernel, Debian boot, the Linux Sunshi community, and tons of other individuals who've helped me along the way. So, do people have any questions at this point? I have a few more examples I can dive into, but I wanted to just open up a chance for questions. All right, let's keep rolling then. So, some quick hacks. So when you're building a kernel from the Debian packaging, one of the things I find really useful to do is to disable the RT feature set, because it basically means you need to rebuild the kernel twice every time you build the kernel, because you're building once for the regular kernel and then once for the RT feature set. And sometimes if you're updating to a newer version, the patch sets won't apply, and if you're lazy, you just comment them out and hope somebody else will sort it out later. So I disable kind of extraneous targets that I don't need to build. It'll speed up my kernel builds. Also, since I don't have the signing keys, I like to disable them because otherwise the builds fail to work. So those are some tricks I use. And this is basically the command line argument I use when I'm cross-building a package because it just builds so much faster on an x86 hardware. So that's about it. Now, do you have any questions?
Can we clap hands, or do you have more examples?
What's that?
Can we clap hands now, or do you have more examples?
Yeah, bring on the questions, please. Oh, yeah, clapping. That was not a question.
There's a question
but I see
coming.
one coming.
Not so much a question, but a comment about the trusted firmware thing. The reason for it going to TFA is that's for Cortex-A. TFM is also a thing for Cortex-M, if that makes it clearer.
Not really, but thank you.
But good stuff. It's nice to see lots and lots of useful work going on, and thank you for being a sensible U-boot maintainer. We need that.
Yeah. Yeah. I didn't want to go through the process of thanking individuals because there are so many of them. But one individual who's been really helpful to me personally working on U-boot is Marek Vasut. He's one of the U-boot upstreams, and he might taunt me on occasion, but he's also very, very helpful, and particularly has helped me move along in a lot of these, getting some things upstream, above and beyond just typo fixes that Lintian catches, though that is valuable. So, yeah. Another question? Anybody? I maintain a board of like 20-some, I maintain a build farm of 20-some computers. Surely, I don't know. Got any questions about that?
Yeah, I do have a question about that. So I'm, with another hat on, I'm with the Zen project. We have a CI thing that tries to do testing of Zen on bare metal hardware, and these ARM dev boards are a complete pain in the backside. Do you have any magic, like little hardware widgets or tips or ways of putting this in a data center that doesn't involve covering everything in plywood dust?
Sadly, not much. If you're really doing tests for specific dev boards, you're maybe even a little bit ahead of me on that. But yeah, I mean, earlier in the ARM-BOF, it does sound like there's actual server-grade hardware to do some kind of testing on now that is available or nearly available.
We have some of that, yes.
Yeah.
The ARM30, there's basically no server ARM32 stuff.
Right.
And since Zen still supports ARM32, and I think we're going to be supporting it for some time, it will be, we want to test that on real hardware. We do have some real hardware that we test it on. Yeah, it's very annoying.
Yeah.
Just one last question.
Not exactly a question, but about the title of your talk. And well, it happened to me that I got a new board, set it up, connected, power it on, put it on a desk. Then I opened the window to let the cat in. It was raining, so the cat thought that that board, which was warm, is the most comfortable thing to lie on. Fortunately, the board survived, and well, I have since joined as a non-ARM team, but I need to warn you that herding cats and boards are not compatible.
Thank you for the warning. My build farm does like produce 300 watts of heat, so yeah, a tempting place for cats. And thank you for bringing cats to my discussion about cats.
Thank you very much, Vagrant.
Thank you.